Comets are simple. Ice and dust. Sunlight pushes particles away. A tail forms. Predictable.
But this one is different.
It's just a big comet, Anna.
The tail is too large, too bright. The mass loss is impossible.
Fragmentation. The nucleus is breaking up. It explains the excess debris.
Are we still tracking this thing, Anna? It's just ice and rock.
It's shedding velocity too quickly, Ben. It's not a comet. It's a vessel. The pieces aren't scattering. Look at the trajectory data.
What? That doesn't make sense.
It wasn't breaking up, it was opening, unfurling.
It's like a solar sail, using the sun to slow down.
Slowing down? Why would it? It's not natural.
Exactly. It's not a comet. It's a ship.
And it's been braking for months, aiming straight for us.
Hey space fans, have you ever looked up at the night sky and wondered what secrets it holds? Well, get ready for a story that sounds like it's straight out of a science fiction movie. We're diving deep into the mystery of a truly bizarre object that has astronomers scratching their heads. Comet 3I, Atlas. This isn't just any comet. It's a cosmic enigma that's breaking all the rules we thought we knew. So, what's the big deal? Back in December 2019, the Atlas survey that as the Extraterrestrial Impact Last Alert System in Hawaii spotted a faint object moving through our solar system. At first, it seemed like a typical comet, a chunk of ice and rock from the outer reaches. Astronomers named it Scene 2019 Y4, but it soon became clear this was no ordinary visitor. It was an interstellar object, the third one ever detected, earning it the new name 3I Atlas. That stands for interstellar, meaning it came from another star system entirely. As it got closer to the sun, something incredible happened. It started to brighten up, just as comets do when solar radiation vaporizes their ice, creating a glowing coma and a tail. But then, things got weird, really weird. Instead of just forming a normal tail, 3I Atlas began to disintegrate. It broke apart into smaller pieces, which isn't unheard of for comets under the intense pressure of the sun. But the real shocker was what happened next. Astronomers watching through powerful telescopes, including the legendary Hubble Space Telescope, witnessed something they had never seen before. After the main nucleus shattered, one of the fragments developed a tail. That's normal. But then, over the course of just 2 days, this tail expanded at an unbelievable speed, growing in one direction and then fanning out like a giant, ghostly wing. This rapid, one-sided expansion is what has the entire astronomical community buzzing. It defies our current models of how comets behave. Let's break down why this is so puzzling. A comet's tail is usually formed by two main forces: solar radiation pressure, which pushes dust particles away from the sun, and the solar wind, which sweeps away ionized gas. These processes create the two familiar tails we often see: a curved dust tail and a straight ion tail, both pointing away from the sun. The behavior of 3I Atlas doesn't fit this picture at all. The tail didn't just grow, it seemed to explode outwards in a specific direction and with incredible velocity. One of the leading researchers, Quanzi Yi from the University of Maryland, described it perfectly. He said it was as if someone turned on a giant, invisible hairdryer in space, blowing the comet's dust away at high speed. The material was ejected so quickly and in such a peculiar fan shape that our existing physics models just can't account for it. What could possibly cause such a rapid, directional burst of energy? Scientists have been scrambling to come up with theories. The first thought was that a chunk of the comet's nucleus, which was already spinning, suddenly released a massive plume of dust and gas. As the fragment spun, it could have sprayed material out like a sprinkler, creating the fan shape. This is known as the rotating nucleus theory. It's a plausible idea, but it doesn't fully explain the sheer speed of the expansion. The dust particles were accelerated to velocities that are hard to justify with just sublimating ice. Another, more exotic theory is that the fragment itself exploded. Maybe there were volatile materials, like frozen carbon monoxide or carbon dioxide, trapped deep inside. When exposed to sunlight, these supervolatile ices could have turned to gas almost instantaneously, causing a violent eruption that blasted the dust away. Think of it like shaking a soda can and then opening it, but on a cosmic scale, and with a force strong enough to create a tail visible from millions of miles away. This explosive sublimation model could explain the high speeds, but the one-sided nature of the blast is still a bit of a puzzle. What's even more fascinating is the origin of 3I, Atlas, because it's an interstellar object. It carries clues about the planetary system it came from. Its composition, its structure, how it reacts to our sun, all of these are pieces of a puzzle from a distant, unknown star. The fact that it behaved so strangely suggests that the building blocks of comets in other star systems might be fundamentally different from those in our own. Perhaps comets in its home system are richer in those highly volatile ices, making them more prone to these explosive outbursts. This event has opened up a whole new kind of cosmic worms. It forces us to reconsider our fundamental understanding of comets. Are they all just dirty snowballs, or are some of them cosmic firecrackers waiting to go off? The data collected from 3I, Atlas, is a gold mine for scientists. Every image, every measurement of the dust's speed and direction is a vital clue in solving this mystery. The Hubble Space Telescope was absolutely crucial in this discovery. Its sharp vision allowed astronomers to see the fine details of the comet's breakup and the subsequent tail expansion. Without Hubble, this bizarre event might have just looked like a fuzzy smudge, and we would have missed this incredible opportunity to witness a new cosmic phenomenon in action. It is a testament to the power of our observatories and the importance of keeping our eyes on the sky. So, what happens now? Scientists are meticulously analyzing the Hubble data, running complex computer simulations to try and replicate the event. They're testing all the different theories: the spinning nucleus, the explosive sublimation, and maybe even ideas we haven't thought of yet. Each simulation that fails to match the observations tells us something important about what didn't happen, bringing us one step closer to what did. This is how science works. It's not about having all the answers. It's about asking the right questions and chasing down the evidence, even when it leads to strange and unexpected places. The story of 3I, Atlas, is a perfect example of this. It's a reminder that the universe is full of surprises, and there's still so much we have to learn. Every time we point a telescope at the sky, we have the chance to discover something that will rewrite the textbooks. For all we know, the strange death of this interstellar visitor could be a common event in other parts of the galaxy. We were just lucky enough to be watching when it happened in our own backyard. It's a thrilling time to be interested in space, as each new discovery, each new mystery, pushes the boundaries of our knowledge further and further. The shocking tale of 3I, Atlas, is a puzzle that astronomers are determined to solve, and will be right here to tell you about it when they do. Thanks for joining me on this journey into the unknown. What do you think caused this cosmic explosion? Let me know your theories in the comments below. And if you love exploring the mysteries of the universe, make sure to hit that subscribe button and ring the bell so you don't miss our next adventure. Until next time, keep looking up.